Operating Apache Kafka clusters requires specialized knowledge for tasks like troubleshooting, sizing, configuring, monitoring, and migrating workloads. Amazon MSK now offers AI agent skills that provide your AI coding assistants with expert guidance for these operational tasks. You can get expert guidance for MSK troubleshooting and sizing by asking questions directly to your coding agent. You can migrate external Kafka clusters to MSK Express, which offers up to 3 times more throughput per broker, scales up to 20 times faster, and reduces recovery time by 90% compared to standard brokers. You can use skills with Kiro, Claude Code, or Cursor, integrating with your existing development workflow. To get started, you configure Agent Toolkit for AWS via CLI, then ask questions like what broker type to use or whether your cluster is compatible with MSK Express. When building multi-tenant applications that execute user or AI-generated code, you need isolated execution environments to prevent malicious code from affecting other users or jobs. Previously, you had to choose between strong isolation, fast launch times, and state retention. Lambda MicroVMs eliminates these trade-offs by providing VM-level isolation through Firecracker virtualization. You can create micro-VM images from your Docker file and deploy them across your workloads. You can launch isolated microVMs with dedicated HTTPS URLs that support HTTP/2, gRPC, and WebSockets, giving each user or job their own compute environment. You can suspend and resume execution for up to 8 hours, preserving state between sessions without keeping resources allocated. You get VM-level isolation with near-instant launch speeds, enabling you to securely run code in interactive coding environments, data analytics platforms, coding assistants, and vulnerability scanning platforms without managing virtualization infrastructure. When running batch workloads, you need to optimize instance selection based on your specific performance requirements rather than relying solely on AWS default allocation logic. AWS Batch now supports 2 customer-ordered allocation strategies that give you control over instance type prioritization. You can define instance type ordering for your compute environments by specifying best_fit_progressive_ordered for on-demand instances or spot_capacity_optimized_prioritized for spot instances. You provide an ordered list of instance types or families that matches your workload characteristics. You configure these strategies through the Create Compute Environment or Update Compute Environment API calls, or through the AWS Batch Management Console. These strategies are available in all AWS regions where AWS Batch operates. Organizations managing thousands of AWS accounts previously faced a constraint where adding accounts and applications consumed capacity from a shared quota pool. This meant that you could run out of capacity for one resource type while trying to scale the other. IAM Identity Center now provides separate quotas for AWS accounts and applications. You can configure up to 7,000 AWS accounts independently without affecting your application quota. You can configure up to 7,000 applications independently without consuming account capacity. If you need higher limits, you can request quota increases through the AWS Service Quotas console. If you already had higher limits configured, those limits are automatically applied to both accounts and applications with no action required on your part. This separation allows you to scale accounts and applications based on your specific needs without trade-offs between the 2 resource types. Previously, AWS Network Firewall used a bidirectional drop action as the default for stateful rules, which could silently drop legitimate server-to-client TCP packets like window updates, keep alives, and resets. This caused intermittent connection failures that were difficult to diagnose in your VPC network protections. The new default changes to server-directed only drop action for all newly created firewall policies, which prevents blocking legitimate TCP flow control packets while maintaining security. You benefit from this change automatically when creating new policies without requiring any action. If your existing environment needs bidirectional dropping to support post-quantum cryptography fragmented TLS handshakes, you can switch back to the previous behavior or add the 2_server flag to your TCP drop rules. This update is available across all AWS regions where Network Firewall operates.